In this video, we'll be learning about the next method to calculate the delay in microcontroller. Before starting with that, we should know that the second method is about using timers. There are two timers in 8051, timer 0 and timer 1. Before understanding the delay calculation, we have to understand the T-mode register. As you can see that it is an 8-bit register. The upper 4 bits has been reserved for timer 1, whereas the lower 4 bits are for timer 0. Individual timers have been subdivided as gate, CT bar, M1, M0, where M1, M0 represents the mode which you will be using, operating mode. C, T bar, C/T bar represent whether the timer would be used for counters or as timers. The difference between the two will be explained in this video. Whereas gate is something which I'll be explaining in the interrupt. As of now, you should always keep it 0. Just for the general information, I'll explain that gate is used to provide external control to switch on or switch off the timer. But we'll be covering gate in detail in the interrupts video, whereas you have to keep it 0 for now. And CT bar, I'll explain about that. Timers can be used as counters or as timers. I know the name, like it is given as timers, but yes, see, if you are using the timers, the timer 1 and timer 0 as timers, the source of clock would be the local oscillator frequency. For like as it was explained earlier, it is 11.0592, the local oscillator frequency of 8051. Whereas if you are using so the machine cycle width, that is the time for one machine cycle, was around 1.059. Yes, it was 1.059. Sorry for the mistake. For 11.0592 MHz local oscillator frequency, the machine cycle was 1.085 microseconds. So if you are using CT bar as 0, that is as timers, the source of clock would be the local oscillators. Whereas if CT bar is 1, that is if you are using the timers as counters, then the source of clock would be the external event that will be happening. For example, if you have an infrared sensor and if a person is crossing the infrared sensor and the light gets blocked, so this external event would be counted as one pulse which will be sent, and such an external event can be used to update the timer. So basically that's the difference. If you are using C as a counter, some external event could be used to update the update the register value, basically register value of the timer. If you still have any doubts on this counters and timers, you can mention in the comment section. Next is the operating mode. Basically there are 4 operating modes of these timers. Mode 0 is 13-bit timer, mode 2 is 16-bit, mode 3 is 8-bit auto reload, whereas mode 4 is the split timer mode. Mode 0 and mode 3 mode 3 is the split timer mode. Mode 0 and mode 3 is not being used so frequently. We'll be using mode 1 and mode 2 very frequently. As in the previous way of delay, we were using different kinds of registers. Even timers has their own register. It is surprising to see here that in using timers you can have a 16-bit register for timer 0 as well as a 16-bit register for timer 1. So but 8051 supports only 8 bits, so timer 0 is divided into 2 separate registers, TH0 which is for the higher 8 bits and TL0 for the lower 8 bits, and similarly for timer 1, that is TH1 and TL1. So explaining you about the modes, if you are using as mode 1, that is a 16-bit timer counter, then the entire 16 bits from D0 to D15 would be used as a timer. Whereas if you are using at mode 1, then only D0 to D7 would be used to store the register value, that is it would be an 8-bit timer and the value to be updated will be stored in TL0. It will be more clear. Let's just move to timer 1, right? That is mode 1 as of now. So let me explain you how the timer works and then you will be cleared. see, in this 8051, if you are using it as mode 1, then entire D0 to D15 would be available for you. That means 16 bits are available. So 62 raised to 16 is 65535. Just a second. It is in hex. It would be FFFF. So FFFF in decimal is 65535. Yeah, so if you're using it as mode 1, then entire 16 bits are available. So the maximum count that the register can hold is FFFF, that's in hex. If you convert into decimal, it's 65535. So let's say if you want to delay for about 3 machine cycles, right? Listen this carefully. If you want to delay it for 3 machine cycles, so the count which you have to upload in TH0 and TL1 would be FFFF, it is 3, right, minus 3, right? So which gives you, let's check this out on Calci as well. Hex FFFF minus 3 gives you FFFC. So this is for 3 machine cycles, right? So the value which you will be uploading in TH0 and TL0 would be FF in this TH0 and FC in TL0, because the way this works is it starts counting. Let's say there's a one second. I'll explain you how it works. For this, let's just have a look at this. This is a T1 register. So you was counting for 3 machine cycles, right? Yeah, so the count which you have to upload is FFFC, that is FFF minus 3. FFFF minus 3, that is FFFC. Yeah, so how it works, see, if you want to count 3 machine cycles, then you have to subtract 3 from 65535. The reason for this is you can monitor that 3 machine cycles have been updated only when this TF flag goes high. This TF flag will go high whenever there is an shift from 65535 to 65536. Say if you upload 0000 in TH0 and TL0, and after 3 machine cycles you won't be able to know whether my 3 machine cycles have passed or not. So in order to check whether your 3 machine cycles have passed and you have to take some other action, then you have to keep on monitoring this TF flag, and this TF flag always goes high whenever there is a shift from 65535 to 65536, right? So you have to subtract, say you have to calculate 4 machine cycles, then you have to subtract 4 from 65535, that is 65535 minus 4 would give you 6553. Sorry for the interruption. So 65535 minus 4 would give you 65531. So in hexadecimal it would be FFFB. Yeah, I hope you got it how you are going to calculate this. See, this TF1 and TF0 are the 2 flags which you have to keep on monitoring. TF0 is for timer 0 and TF1 is for timer 1. TR1 and TR0 are used to start the timer, like you have to indicate the microcontroller that you have to start the timer. Bear with me right now, like you will be more clear about this once we do the programming video in the next programming concept, like we'll solve a program in the next video. So right now just have a look at it and just go through it. What is TF1, TF0? I have tried my best to explain it to you. In the next video we'll be solving a program and you'll be more clear about that. Thank you.